And coming to the different transformations on DStreams, again the operations, these are also again two types, the stateless transformations and stateful transformations. And in stateless transformations, you assume all the RDD operations that you have seen so far, those are the examples for your stateless. And stateful, again in stateful, we have two types. So they are like window-based stateful transformations, and second one is a state by based on a stateful transformations, update state. Okay, so here what is mean by stateful transformation and how is it different from stateless? Whatever the stateless transformations that you apply, so this answers some of the questions that you raised last week. Stateless transformations give you the results for that particular batch only. They does not depend on the data of its previous batches. So technically speaking, so the same methods, the same operations that you can do on RDDs. But the functionality wise, the results of these stateless transformations you will get only for a particular batch. So once you read some few lines of data in that batch, so only on that batch of, so during that batch, how many are the word counts that you receive? Those are the ones that you have seen so far. So that is nothing but your stateless transformations. On the other hand, if you want to carry forward the state starting from the beginning, that is where you have to use update state by stateful transformations. There are two types of stateful transformations I was telling, right? So where you need the state starting from the beginning of your streaming. So once you started streaming of your data, so starting from there till the end of, till when you close your, stop your agent, until then you need the state. So that is where we need to keep on producing using update state by. And the second type of stateful transformation is that instead of starting with the beginning of the streaming, so you always need your aggregates for last 5 minutes or last 10 minutes or last 30 minutes. You don't want starting from the beginning, just from last 5 minutes, just from last 10 minutes. If that is the case, that is called as a window. Always that last 10 minutes or last 5 minutes is the window. So during that window, how many are the batches that you receive? For all those batches, you will get the state. State get carried forward. And if you see some of the example operations and you will see the examples, you will get to know more and more. Okay, the definition lines may not make you completely clear, but let me show you some examples and then you will understand that. So the stateless transformations, typical your map, flat map, filter, the repartitioning. This is also one of the operation on DStream that you can divide this into number of partitions. Reduce by key, if it is a key value pair. Group by key, it's another key value pair. So these are the examples for your stateless transformations and stateless DStream transformations on two DStreams. Maybe join, co-group. Okay. And stateful transformations, as I was telling, there are mainly two types. So windowed operations and update state by key, which is used to track state across events for each key stateful transformations across events for each key. And generally, this stateful transformation requires checkpointing that we'll discuss anyway in the separate slides. And these are the types or the examples for stateful transformations. So the first one is the update state by key. This is the only flavor that we have. And for windowed operations, we have multiple types. So one is a window, count by window, and reduce by key and window. If it is for key value pair DStreams or RDDs. This is for regular ones. And this is for count by value and window. This is again on like your key value pairs. Okay, so we'll see those examples one by one instead of explaining here. Okay. So update state by key. So update state by key operation allows you to maintain arbitrary state while continuously updating it with new information. To use this, we'll have to do 2 steps. Or a simple example I can specify. So if you want to keep on counting, so you need a status that, so how many total records or how many total elements that were processed so far, that were ingested so far. So if you make that as one state, so whenever you send any list to it, I will define a function. So that function takes the list as an input and the current state. So when I'm processing the first batch, so that time my state might be 0. And when I'm processing the second batch, second window, then, so already I might have seen such kind of elements as 10. And now, if I receive 5 more in the next batch, I should increment that for that particular key, right?
Shiva, if possible, will you please explain this again?
I'm still continuing that. Okay. So let's say, so you have a streaming of data. This is one batch and this is another batch and this is another batch. Okay. Here. So here you maintain some like set key value pairs, like some color, yellow 5 and blue 2 and red 1. So this way, let's assume some string comma count or its price or some tag, some tag you're getting in the batches. Now, so your goal is to, at the end of day, at any point of time, you need the total count till that time. Not just for one batch. I'm not expecting for each batch. I need, so how many total yellows, how many total red flags or so tags or whatever it is. Okay, so in this batch I have received this many. In the next batch I might have the value as 1, and in the subsequent batch the subsequent batch, I might not get this. For a particular 1 second window, I might not get any yellow records. And for this, again after that, I might receive 2. Similarly, this. Here I may not get it. In this window, in this batch, I might not get it. But here, I might get 1. Here, I might get it as 2. Now, at any point of time, if I take the counts, if I want to do anything, here I should get as y, 5 and b, 2 and r, 1. But here, in the next batch, when I run, this should become y, 6 and b, still 2, and let's assume r is remaining the same, r, 1. And in the next batch, y remains same, y, 6 and b, so this time b, 3 and r remains same. Now y becomes 8 and b becomes 5. So that means your state, so here you had a state of 5. Your status or the state for your y was 5 while crossing this batch. And when crossing the next batch, it is depending on the previous batch value. Or on the other hand, it is carry forwarding the previous batch's state to the next batch. And that state is getting carry forwarded to the next batch. That state is carry forwarded to the next batch. So this is nothing but update the state by key type of operations, where you need, so at any point of time, so what is the state starting from the beginning. So if you want to compare these examples, the better example I can give you is cricket scores. So cricket scores, when starting from the match started, so at any point of time, this is like your scorecard. So entire your scorecard, like at whatever time I ask you, you should give me the latest count or latest score for each player. Okay, so if you just take this as, so for each player, what is the latest score at any point of time? If I ask you after 5 seconds, that particular window, what is the latest value? So you have to give me that. Next, coming to the second type of operations, those are window-based operations. So there, again in the scorecards, you might see sometimes in the messages, last 5 hours runs 35 wickets 2 or something, and run rate so and so 7.0 or something. Okay, so here last 5 hours is the window, right? At any point of time you will calculate these numbers only for the last 5 hours. If you are running on the 30th over, so second ball, then it considers starting from 25th over, second ball onwards, where you can take each ball as a 1 second and 1 window, 1 batch size. Every 1 second as batch, and you included 5 overs means 5 into 6, 30 seconds or 30 batches in 1 window. Or you might see in terms of time also sometimes, or last 10 minutes or last 30 minutes. can say 60 runs or whatever it is, 30 runs, wicket so many, and run rate. Okay. So if you just, whenever you use last, that is last 10 minutes or last 20 minutes, last 30 minutes, that is a window based operation. Instead, that starting from the beginning, what is the latest state? That is nothing but update state by key. Okay. So example how to implement this update state by key is like, so update running sum. We have to build a function for this. We need to build or implement a method. So to use this, we'll have to do two steps. Define the state. The state can be an arbitrary data type. And define the state update function. Define the state update function. Specify with a function how to update the state using the previous state and the new values from an input stream. Okay, so here if you take, this is one of the state update function, update running sum. So it takes a new collection values sequence of long. So these are nothing but the numbers that are, or the values or the data that comes from your input DStream, and this is the state option of long. Equal to sum of, so I'm using sum method. So if there is a value, that will get returned, otherwise none from a particular DStream. State.get or else of 0L. In this state, for the first DStream, there won't be any value. That time 0L will be returned. 0L will means 0 will be returned. So from the next batch onwards, the state will be, the actual value will be returned. Now for the first DStream, so 0 plus values dot size, that will be returned here. And for the next, the same state will be carried forwarded. When it's processing the next batch stream, then that value will be get here, and the next value, that stream's size will get added to that. So that way it keeps on getting added for every batch. And once you have the state update running some method, that you have to use in this update state by key method. So let's say val response codes DStream. So response code DStream access logs DStream.map. For every log.get response code. Get the response code and maintain its count as 1, and response code count to DStream. Response code DStream.update state by key. So provide your method. And all the values for all the similar kind of keys, it collects all the values and sums them up and it returns them. That means at any point of time, how many status 200 ports received, how many 404s received, how many 505 pages received, page not found, or 404, server not running. Okay, that is one example. And the next one is, if you take just very simple one, let's say I have a tweet messages, and in my Twitter at different times I can set my different mode status, right? So I can set feeling exciting, feeling boring, feeling sleepy. I can set different statuses in my Twitter. So in my tweets I can set my status So those status can be changing at different times. That means that always keeps on updating. And in these cases, it doesn't make sense to take any averages or these things for last 10 minutes or last 5 minutes kind of. You always need the latest updated mode or status, right? So let's say in t-1 he's having a different mode, and t is having different mode, and this time is. So always you have to give the latest mode. Okay. Next, let me take these two examples also, and then I will show you the example with Twitter program, and I will run that. Now, so the window operations. So window operation is nothing but the same as I was telling you. So if you consider this a few batches into your window, so here again you will have two parameters, two time parameters that we specify. One for batch size. Batch size might be 1 second or 5 seconds or 10 seconds. Anything can be your batch size. And what is your window size? So with that, you will specify window of your window size and comma batch size. For example, if you see here on your DStream, so access logs DStream dot window of seconds of 30 means every 30 seconds. So for last 30 seconds, so what is happening? So seconds of 30 seconds is the window, but your batch size itself is 10 seconds. That means every window you will see 3 batches. Now any counts that you prepare against this windowed DStream, that means you will get all those values for last 3 batches, the status for last 3 batches. And all windowed operations need 2 parameters, window duration and sliding window duration, both of which must be a multiple of streaming context batch interval. Multiples of so most of the times we maintain this, the second parameter equal to the batch size, batch interval, or in the worst case the integral multiples of your batch interval. If your batch interval is 0.3 seconds, so you can't maintain seconds sliding interval as 1 second or something like that. Just it needs to be always integral multiples of that. Okay, and as a standard or I mean there is not much standards also I can specify to you. As I am telling, this is more of like a still in evolving phase and incubating phase. So you might be using this Spark streaming mostly for your basic kind of POCs, not even for complete real time, unless until you get any enterprise supports for these things. Okay, even if you do anything production, that may not be that business critical. Okay. Now, yeah, just as an example, Twitter stream, I got the DStream and I applied some flat map, and again I got another DStream. On that, I'm applying my window operations, like window of minutes of 1 and seconds of 1. Means 1 minute is my window and 1 second is my batch or sliding window interval. So count by value, that means the values count will be given to you always for the last 1 minute. So if you imagine this, so this is how your data gets streaming. Okay, so data gets streaming continuously. So at any point of time you take your data. So let's say this is your last 1 minute and you have this many batches in this 1 minute window, and you will get your tag counts for this minute. Next, if the time changes, that's the window length and sliding interval. If the time, so let's say if the sliding interval is double the batch size, your batch size is half second. When you create your streaming context, so you have specified as a batch interval as just half second. Then every slide you will include 2 batches. Okay. So next, this is the next. If you slide two batches to the left side, so for the next calculations, this will become the next window, and that gives you the latest count. And again, after another 1 second, so these 2 batches will be excluded, and here 2 more batches will be included into the computation. That way, your window will get slided towards the new data. Okay. At any point of time, if you take at different seconds, you have these hashtags, the same hashtag. So if your sliding window, so and so, if you consider this is your window, and you got your so and so count overall the data in that window. For the next second, 1 second pass, your window will get moved, and you will get total count by using these batches. Okay. So those are the stateful transformations, both the update state by key and window operations. And the last one that you can do on your DStreams is output operations. Either you specify to save them as text file or print them anyway we have seen so far. So printing them we have seen already, save as text files or save as Hadoop files. This is the ones that we see. Object files, we don't use them because they are like, okay, object files is nothing but saving them as a sequence files. Okay, so here the prefix, what is the prefix for each one of those files, and what is the suffix, and it uses the timestamp in between them and stores them into that path. You can see that example now. Okay. Now so before checking that, I might be using the RDD checkpointing also there. So we talked about this already while we were discussing the RDDs. Again, to reiterate it in this concept, especially in stateful transformations. In stateful transformations, if you take each batch as one RDD, so every RDD is dependent on the previous RDD, correct? So that means if you have 100 batches in a particular window, even if you take windowed operations. So in that particular window, all the batches are dependent on the previous set of batches. So let's say if you are at 100th batch, 100th batch is dependent on 99th batch, and 99th batch is dependent on 98th, and 98th batch is dependent on. That way, starting from first batch to 100th batch, they are depending on in sequence, one on the other, if it is a window operation. If it is update state by key, starting from the beginning, all the RDDs are depending on the previous batch. That means at any point of time, if any of this RDD's data is lost, that means to calculate that, it has to start from the beginning. If you are performing any action of the RDD status, it has to start performing the actions from beginning. So instead of doing that, for recomputing that, so in order to start from, as I was telling you, right, whenever if you perform an action, then only the data will be coming into that RDD. So if that RDD itself is lost, in order to recompute that, again, whenever you run an action, that will start from the beginning. So it has to start from the beginning. So let's say if you have these many, so you have, this is your latest, or this is how, starting from here, you are building your RDDs this way. So if you store this somewhere on your disk, RDD.checkpoint, so this, instead of performing all these things, you have stored the contents of RDD, the red RDD, saved into HDFS file. So from next time onwards, even if you lost this, so you can read your data from here. That's the point of maintaining your checkpoint. Okay, stateful DStream operators can have infinite lineages. So large lineages lead to large closure of the RDD object, large task sizes, high task launch times, high recovery times under failures. That's the reason. So at regular intervals, it's always better to checkpoint them. So periodic RDD checkpointing solves this. You don't need to checkpoint every RDD. So periodic checkpointing will solve that purpose. Okay, and RDD checkpointing needs to be determined again like a trail and error basis. You should start with, you should not checkpoint too frequent, which will make your process go slow down, because of HDFS writing will slow things down. So checkpointing too infrequent, again, so there is a risk that task launch times, like all of a sudden, after all the so many task lineages happen, once you run an action, it has to start computation from the beginning. So then it will be taking a lot of time. Okay, so default settings checkpointing is at most like once in 10 seconds. So this is the default setting that is recommended to start with. Try to checkpoint once in about every 10 seconds. To checkpoint, as we have seen in the Spark shells, the same way, we have to specify the checkpoint directory for that Spark streaming, and whenever you checkpoint an RDD or DStream, that will get written onto the listing. And this is persisting your DStreams or catching your DStreams can also be done. So the same RDD catching that we have seen, the same stuff, nothing different. Okay. Only the difference is that difference from RDD's default level, where in RDDs, whenever you persist an RDD, so that was getting persisted only in memory only. The default storage level was memory only, but here memory only underscore serializer. Okay, which means it will get stored in the memory but in a serialized form, because these DStreams needs to be copied onto one machine to another machine, so where you need the data to be serialized. Okay, performance